Hello. Test, 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 test. 1, 2, 3, 1, 2, 3. Good evening, everybody. We'll be waiting to see if anybody else would like to join this live stream. Thank you for watching if you are. Good afternoon, everybody. This is Andrew Coburn once again, here with NPR, where we talk very close and directly into the microphone and very softly, and yet the volume is very loud for our voices. I'm almost peaking right now. It's ridiculous. Today, on today's menu, we'll be showing you exactly how to add more features to our compound interest calculator. And we'll show you how to add things like monthly payments, how much interest you're paying or gaining from your compound investment, and it's all going to be shown to you here on our YouTube channel. If you like our stuff, please subscribe. And without further ado, we'll go ahead and get started. And I'll stop talking like this because I'm going to move further away from the microphone. Okay, so the first thing we want to do is we'll go ahead and we'll open up our yesterday's project, compound interest live stream. And it'll load, ideally, today, maybe. There we go. Oh, we're getting somewhere. Okay, so once it finishes loading, yes, we'll hit F5, and I'll show you what it does. If it decides to work, which would be, great. And while you're waiting, I'm waiting to get back to my Creator Studio. Yes, perfect. Yes, there we go. Okay, first thing we'll do is we'll go ahead and enter a sample. So for the example that we did yesterday, it was from a formula that we got off the internet. We'll do 5,000 is our principal amount. Interest rate will be about 10%. Enter 10 years, and compounded annually 12, once a month. And this is what we get. And the way we have this set up is it shows you how much interest, if this was a loan, this is showing you per year how much interest you would be paying, along with how much money, say for example, if you borrowed $5,000 at 10% interest, you would be paying $5,523.57 if you borrowed it for 1 year. For 2 years, you would be paying $6,101.95, all the way up to 10 years, $13,530. I know that's a lot of money to be paying for $5,000, but that's how banks work. So what this is doing is it's showing you all the calculations for each and every year up to 10 years. So what we're going to do is we're going to add some features to this. We're going to calculate how much you would be paying per month if you were trying to pay this loan off. Now, keep in mind that you have different things. For example, like normally you have a down payment, but if you're doing an investment where you put $5,000 into a bank account, you're obviously not going to have a down payment. You're not going to subtract any amount of money from your original principal. Now, if you're doing a mortgage or a car loan, that's something different. So
let's go ahead and let's calculate how much interest per month you're earning, basically. And the way we would do that is, first off, let's go ahead and get rid of this right here. Okay, awesome. We don't need that because then we'll do it times, we need to change that to principal time. So let's go ahead and run our program again just to make sure it works. No. Okay. I already know it doesn't work. Why? I do not know. Oh, I see. Because we need to do principal time. Perfect. Awesome. Now let's try it again. There we go. Awesome. 5,000. Interest rate is 5%. 10 years. 12 times. Perfect. That's exactly what we want. That's exactly the same. That matches our old formula that we had done. Perfect. That's all we need. If you're gonna, except we have our wording wrong. That's the only other issue. That's all we had to get rid of for it to make sense. But so now we have that. Now if we want to see how much interest we're gaining, we can go ahead and we can also do this. We'll go ahead and we'll define another double variable up here. We'll call it accumulated interest. Simple as that. And then we'll go ahead and define it down here. Accumulated interest equals, and then we'll do total. I'm sorry. Yes, total. Minus principal amount. And then we'll do a right line. And we'll type you will earn Alright. And what I'm typing in again is these are just little arrays, kind of, saying that this will represent this curly bracket, 0, curly bracket, close curly bracket will represent the first variable that I put here, which is going to be accumulated interest, comma, and the one inside the curly brackets is going to be the next variable, which is going to be principal time. And then the only other thing we need to do is we need to type dot to string C. Oop. And the reason for that is it converts our double into a currency format for string. And we need to do the same thing. Oh, we don't need to do the same thing for time. Principal time can just stay the same because that's never going to have a decimal. If it does, there's a problem with your program. So let's go ahead, F5 it. Let's go ahead again. Let's do principal amount is $5,000. Enter. Interest rate is going to be 5%. Years of loan investment will be 10 years. And it's compounded 12 times a year. So your total is $8,235.05. and you'll earn $3,000, $235.05 in interest over 10 years. The only thing we can fix is adding years to the end where it says 10, because that would make more sense. Period. That would make it more sense. Awesome. So that's how you calculate how much that's calculating how much you're going to have for your. They'll show you how much interest you're gaining in your savings account. To make it a little more generic, because we want this program to be for both mortgages and credit cards and things like that, and debts where you need to where you'll have a down payment. So let's go ahead and add that. We'll go ahead and we'll add another double. We'll call it down payment, and we'll add we forgot to add a comma right here, which is no biggie. And it's, again, to recap from yesterday, the reason why this turns green at the bottom giving you an error is because we haven't defined or used this variable yet, and Visual Studio doesn't like that. You know, C# won't like that either. It'll just be like, why, you know, what the fuck, you're wasting memory. So we'll go ahead and after our principal amount, we'll go ahead and add in a right line. It'll be enter down payment percentage. So, for example, if you're going to get a mortgage, they ask for 20%. They ask for 20% of the amount you're trying to borrow up front as a down payment. No big deal. That's what banks always do. If you want to buy a house, that's what you got to do. Same thing with car loans. You have to have a down payment. Usually it's a percentage. So we'll go ahead and we'll ask the user for that. And then we'll call it down payment. And then we'll do the same thing again as we did for all the other variables. Convert to... helps if you spell convert right, that's why. To double. And then we'll do read line. It's a method, so we gotta do those two parentheses. There, boom, look at that. Beautiful. And then after that, we'll go, since it's a percentage, we'll go ahead and divide it by 100, just like we did with the interest rate. Now, how does that factor in with your down payment? Well, we'll go ahead and what we'll do is we'll go ahead and we will subtract the principal amount. We'll have to change our formula that we're using, obviously. We'll do one more variable. We'll call it after down. And we'll bring it down here. And we'll type after down equals principal amount minus down payment. And then instead of using the original principal amount, We'll pop it after down. So, perfect. Let's give it a shot. Let's see what we get. So let's say we have a $650,000 mortgage. Enter, and they want 20% of it up front, which is not uncommon. And the interest rate is 4.25%. Again, not an uncommon interest rate. And number of years, fixed rate 30 years, and it's compounded 12 times annually, once a month. And your total for 30 years, you'll be paying $2,320,921.44, and you'll be paying about $1.6 million in interest. That's after your. That's after we have deducted the down. Your down payment from. Oh, we forgot to do one thing. I was wondering why something was screwy. We need to multiply. We need to do one more thing. We need to create another variable, and it's going to be we'll call it down pay calc. Because what it'll do is we'll calculate what 20% of So we'll do principal amount. Oh. So that's why it's important to hit the tab button and not, there we go, times down payment. And then instead of principal amount minus down payment, because down payment is going to be like 0.20 anyways, that makes no difference. That's why we were having an issue. I was wondering why the numbers didn't come up right. So we'll do down payment calc minus down payment. Now we should get a better answer. So let's go ahead and type in $650,000 for our principal loan, and they want a 20% down payment. Interest rate is 4.25% interest fixed for 30 years, compounded 12 times. There we go. So you wind up paying $464,000. That still doesn't make sense. So this is also a little trick. You can figure out what's going on. You can, if you want to see what's going on with your project, go ahead and we'll show you how to debug. So we'll start there. We'll start the program. Now, what this is effectively doing is you can control how quickly the program works with these buttons up here. You have the step into button. This is the show next statement. Doesn't execute anything. This is step over, so it'll go over the next line. This is the step out of, so it'll go backwards basically. So for example, we'll step into this right here. And that's what happens in the program. It shows you to enter the principal amount. Notice how if I type, it doesn't do anything. But as soon as I hit this, the characters that I typed in popped up. We don't want that. Our principal amount is going to be $650,000. I know what I did wrong. We don't need to do all that. For here we do principal amount minus down payment calc. That should sort out the issue. Oops. We don't want to debug because we know what the issue was. So again, 650,000. Down payment percentage is 20%. Interest rate is going to be 4.25%. Years of 30-year loan fixed, 12 compounded 12 times a year. That's exactly what we're looking for. That's right. You will be paying $1.8 million, roughly $1,856,737.73, and you'll be paying $1.2 million in interest over 30 years. You know, that's after your and for a car loan, it works a little differently. Let's go ahead and let's Google car loan down payment. Interest rates as low as 2.9 APR. APR is different than a fixed rate. APR is annual percentage rate. So that means if you get a 5-year loan on a car, you'll be paying not a fixed rate. They will be changing your annual percentage rate based on profit margins, and there's no control over that. It could go up, it could go down. You really don't know. Let's do percent. Nothing really tells you what. Okay, so they want, again, it's the same thing, 20%. Alright, so let's say we're balling and we're buying an $80,000 Mercedes. And we're going to pay 20% for 2.29 fixed. We'll do a fixed interest rate. It's a 5-year loan, compounded 12 times annually, and that $80,000 car will wind up costing you $71,000. Something's not right. Oh, it's in parentheses because it's negative. That means something's not right. That's perfect. Dividing by 100. Okay. So let's say you get a $5,000 loan. Down payment is 20%. 5% interest. 10 years. 12. Okay. That makes more sense. Alright. So then why did the 80 not work? Let's try again. So if we pay 80,000, 1, 2, 3, 20% interest, or 20% down payment, the 2.29 interest rate for 5 years, compounded 12 times, That makes no sense. Why is it not working with why is it giving me a negative number? That makes no sense. Oh, I see. We don't want principal amount. We want principal amount minus because total is how much you're paying after interest and down, or paying in interest after down payment. So we'll just go ahead and subtract. We'll do down payment calc. There we go. That should. I think that should do it. There. That should make more sense. So 80,000. 20% down payment. Interest rate is 2.29. 5-year loan, compounded 12 times annually. There we go. That's exactly right. Perfect. So you'd be paying about $7 grand. No, that still didn't make fucking sense. Oh wait, no, it does, because you've already paid the down payment, so it would be lower. That's perfect. That's actually fine. That's actually correct. I forgot to. I'm getting confused with myself with all this mental math. So then, how do we calculate how much your monthly payments are going to be? Easy. We take your principal time. Let's go ahead and do monthly payments. We'll just call it. We'll just go ahead and we'll go back up here. And we'll call another variable. Make another variable called months, and then we'll have to make another variable after that called monthly payments. Perfect. So for the way we'll figure out how many months is there's 12 months in a year. So we'll go ahead and take principal. Wait, we need to define it. We'll call it months equals. Principal time times 12. Easy. Then we'll take total. For monthly, to calculate our monthly payments, we'll do monthly payments equals total divided by months. So, for example, if there's 5 years in the loan, then what this is going to do is multiply the 5 times 12, because there's 12 months in a year. Now all we have to do is a simple right line and your... And what I just typed up is simply your monthly payments for blank years, and where the zero inside the curly brackets is going to be this first variable, and that's going to be principal time. And then the next one will actually be your monthly payments, which I will just go ahead and type monthly payments variable. And that's it. So theoretically, let's try this. Good. So again, $80,000 car. 20% of it's going to be paid upfront. Interest rate will be 2.29. It's a 5-year loan. And how many times compounded? 12 times compounded annually. And something's not right. Let's try this. Convert to string. Try this one more time. 80,000 and 20% down payment. Interest rate will be 2.29 interest. 5-year loan, compounded 12 times a year. Still not right. 7 cents a month for 5 years does not make sense. That's why principal time. There we go. I had the wrong variable plugged in. Okay, 80,000, 1, 2, 3. Down payment is 20%. Interest rate is going to be 2.29% for 5 years, and you'll be compounded 12 times a year. There we go. So if you get a loan for $80,000 and you pay 20% of it up front, and your interest rate is 2.29%, and you do that you pay for 5 years, or you have 5 years to pay it off, you'll be paying $71,756.18 in 5 years. You'll be paying $7,756.18 in interest, and your monthly payments will be $1,195.94. So let's try this with a mortgage. So again, $650,000 home, and your down payment again will be 20%, and you're going to do 4.25 fixed 30-year investment or 30-year loan, compounded 12 times. Perfect. So you'll be paying $1,336,737.73 over 30 years in interest alone. And your mortgage payment will be $5,157.60 a month. That's pretty expensive. Now, of course, if you're not borrowing the money for so long, your interest rate won't be so, the amount you'll pay in interest won't be so bad. I'll give you another example. We'll do the same $650,000 home, 20% down payment, 4.25% interest for, let's do 15 years this time. And you'll be compounded annually 12 times. So you'll be paying $462,600.44 in 15 years, and your mortgage payment will still be the same. Now let's go ahead and see what some banks are offering. So mortgage rates. Let's do 650,000. %. Nope. See? Now that depends, that's the actual loan will wind up being 520,000. Refinance. Now that's a whole different. Let's search for 30-year fixed. See, it all depends on A, how much you throw down. See, what I was trying to show you guys earlier is how this debug process works. And we'll go ahead and show it to you guys again. So basically, let's see if we can set up we'll go ahead and I'll just show it to you this way. So again, I haven't told it to do anything, so we'll go ahead and we'll hit F11, we'll hit this button, and that'll pop this up. So enter principal amount. Let's do 650. Oh, see, it won't let me punch anything in because all I've done is execute that. I haven't executed the read line yet. It's on the read line. It's on this line right here, but it hasn't executed yet. So we'll step into it. And I'll see the text popped up and everything. 1, 2, 3. Hit enter. And that's about it. Then we'll hit step into again. And as you can see, principal amount has changed to 650,000. So the next thing we have to do is we'll type in our mortgage rate of 4.25. Again, I have to hit step in for the text to show, as you can see. Enter. Still nothing. See? Now it's saved and converted my down. Yep. We messed up. Let's go back again. Step in, enter our principal amount, which will be 650,000. Step in. Yep, that's right. Enter. See, it popped up our principal amount right there. Awesome. Then we'll go ahead and step into again. And it's asking us for our down payment percentage, so we'll type 20 for 20. Step in again. Hit enter. As you can see, our down payment has turned into 0.2 because it's taking 0.2. That's the percent. That's what 20% is in decimal form. Then we'll go ahead and step into again. Now it's asking us for our interest rate, which is, again, it's not going to show our text, so 4.25. Until we hit this, step into again. And apparently we have a handle error, which is, I don't understand because it's been working fine throughout this whole process. So let's try this without that. So 1650123 enter, 20 enter, 4.25 enter. See, it worked fine. Maybe I just accidentally hit a goofy number or something. I don't know. I'm crazy. But basically, what this allows you to do when you click, when you click right here, it allows you to go line by line by line in executing your program. And when you do that, it allows you to see what the program is actually doing. So that way, if your math is off and you don't know why, you can actually watch the program work in real time and understand what's going on and hopefully figure out why your code is failing. And that's why it's called debugging. It helps you figure out what's going on with the problem. But I'll get right back up to the microphone for this because we'll do an NPR outro.
Thank you very much, ladies and gentlemen, for watching us on Andrew's afternoon boredom of programming. Again, we're talking very closely to the microphone, much like our folks in NPR do. I'm a Washingtonian, so that's why I'm referencing NPR.